Today we're going to be talking about our last shape and its volume, and that is a sphere, which is a circular ball shape, which hopefully we are all aware of. So make sure we have our volume of spheres notes out in front of us so that we can follow along and get down everything we need. So let's just dive right into the formula for volume of a sphere. It can be found using the formula V equal to 4/3 times pi times radius cubed. So notice how we only have one variable here, and that's our radius, and it's being raised to the third power. Sometimes you might encounter problems where it asks you to find the volume of half of a sphere, and it will use the term hemisphere. So when we see that word, hemisphere, we would want to take the entire sphere's volume and divide it by 2. So quickly, just to see how the sphere formula comes about, it's actually derived by comparing it to a cylinder. So if a cylinder and a sphere had the same radius and the same height, this would mean that the height of your sphere would be 2 times the radius. So if we look down at one of these graphics on the bottom, we know from the center of the sphere to the edge would be a single radius. So if we went from the top of the sphere all the way to the bottom, which is technically representing its height, that would be the diameter, or 2 of the radii. And then of course we have our cylinder, which would have the same radius, and then we would also want its height to be 2 of the radius. So if this is the case, then the sphere will actually have 2/3 the volume of the cylinder. So if they have that same height and the same radius, the sphere will be 2/3 the volume of the cylinder. So what you can look for here is in the table, we have our formula for volume of a cylinder, pi r squared h. Because our height, we are making it 2r, we would replace the h with a 2r. And then, because we just said a sphere would be 2/3 of that, we would multiply the formula by 2/3. You would simplify, multiply the 2 and 2/3, the r squared and r, and that is how we get the 4/3 pi r cubed. That is not something that you need to know or repeat. It's just a cool little way to see how we can get the volume of a sphere from the volume of a cylinder. So let's dive into some practice problems. For all of these problems, we are using 3.14 for pi. And so our formula that we are using throughout these 3 problems will stay the same. Volume is equal to 4/3 times pi times radius cubed. So I'll just copy that across, and then we will look at problem number 1. So plugging in our values, and really we're just plugging in one value, the radius, we get 4/3 times, we're using 3.14 for pi. The radius is given to us as 3, and so we raise that to the third power. I'm going to pull up and split screen with a calculator so we can see what we get as an official volume. So 4/3 would be 4 divided by 3 times 3.14 times 3 to the third power. And we will get 113.04. There are no units here, so we would use units cubed. So same process, just plugging in what we know that we did with the cylinder and the cone, but we only have our number for radius that we're plugging in when we find the volume of a sphere. Moving on to number 2, plugging in our values, we have 4/3 times 3.14 times, now this time we are given our diameter of 12, so we want to cut that in half to get our radius. So our radius would be 6 raised to the third power. When we type that into our calculator, we will get 904.32 units cubed. And then for our final example, to get our volume, we would do 4/3 times 3.14 times our radius, which is given to us as 5 to the third power. Type that into our calculator, ideally our Desmos calculator. Here we are not going to get a terminating decimal, we get a repeating decimal. So I'm just going to write that as 523.3 with the bar units cubed. So like with a cone, because we're multiplying by a fraction, you might sometimes see a volume that has a never-ending decimal. On the next page, we are going to practice leaving our solutions in terms of pi, which we practiced back with our cylinders. So remember, when we find something in terms of pi, we're multiplying everything together but the pi. And then I'm just going to copy that same formula down because the formula we're using does not change. So in this case, we are not going to use 3.14 for pi because we're not actually even multiplying the pi in. So I take my 4/3 multiplied by pi, multiplied by the radius to the third power. Because our diameter is 13, our radius would be 6.5 raised to the third power. So what we need to do is multiply the numbers that are not pi together. So that would be the 4/3 times the 6.5 to the third power. We get a repeating decimal, 366.16 repeating. Because we did not multiply pi in, we need to keep the pi attached at the end to show that it's still part of the problem. And I think these are all unitless as well. So our generic unit would just be units cubed. So when our problem says in terms of pi, you are not multiplying pi in, you're not multiplying 3.14 in, you are just multiplying the other numbers in the formula and then attaching the pi at the end. Number 5, we would have 4/3 times pi times our radius of 12 to the third power. All of these are in terms of pi, so we multiply 4/3 and 12 to the third together. We will get 2,304. That is being multiplied by pi, so 2,304 pi units cubed. Last example of this type, starting with our same formula, 4/3 times pi times the given radius, 9.3, to the third power. Multiply just the 4/3 and then 9.3 to the third power. Get 1,072.476 times pi, which was not multiplied in, units cubed. Remember, when it comes to our test next week, you will be given the formula. So you'll be given the 4/3 pi r cubed. You just need to make sure that you are representing your answer in the way that the instructions tell you to. So when it says in terms of pi, you better have the pi symbol in your final answer. So we are going to finish off this lesson with some application problems or working backwards problems, 7, 8, and 9. So let's take a look at number 7. 7 says we have a hemisphere. So remember from the first page, hemisphere is half of a sphere. And so we would want to find the volume of the entire sphere and then divide it by 2. And we have a radius of 7 inches. We're going to assume here that we'll use 3.14 unless otherwise stated. So the volume of the entire sphere, if we are finding a whole sphere, would be 4/3 times 3.14 times 7 to the third power. But we don't want a whole sphere, we'd want half of a sphere, so we would just take that entire number and divide by 2. We can type that entire thing into Desmos. So what you want to make sure of is everything you're multiplying on top actually needs to go in parentheses. So 4/3 times 3.14 times 7 to the third power, close parentheses, and then I can divide that by 2. So we are going to get a repeating decimal, 718.013 repeating. Doesn't say anything about rounding, so we'll keep that as our final answer. And we do have a unit here, inches cubed. Number 8 is going to be a working backwards problem because we know the volume of our sphere and we need to find the radius. So let's write down our starting formula for a sphere, 4/3 pi r cubed. And then we're going to plug in what we know, and really all that we know is the volume, so that's going to go in on the left-hand side. 288 pi. So we need to be very careful here because what you should notice, or if you don't notice, you should now, is that we have a pi on either side. So we can actually just cancel out those pi's. They cancel each other out, and we will be left with 288 equal to 4/3 times r to the third power. So that's why I kept it as pi and not 3.14, so you could see how it canceled out with the pi in our volume. So our goal is to find the radius, so we want to get r cubed by itself, meaning I have to divide out the 4/3. Because it's being multiplied, the opposite of multiplication is division. So 288 divided by 4/3 gives us 216. And that is r to the third power. So in this working backwards, where it differs from if you were finding the radius in a cylinder or cone problem, we have an r cubed. So in order to get rid of an r cubed, we can't just do the square root. We have to do what is called the cube root because our exponent is different. So in Desmos, you want to go to the n square root button. That'll have a cursor on the outside that we can type in a 3 and then 216. Cube root of 216 is exactly 6. So the radius of this sphere is 6 inches. Okay, and then number 9 is essentially the same problem, just a different volume to start. So if I have a sphere, I know I'm using the formula 4/3 pi r cubed if it's a volume problem. Our volume in this problem is 972 pi inches cubed, and we want the radius. So instead of V, we will put 972 pi equal to 4/3 pi r cubed. Just like the problem that we just did, because both sides have a pi, those can cancel out and we no longer need them in our equation. So our simpler equation is 972 equals 4/3 r cubed. To get r cubed by itself, we would divide out the 4/3 from both sides. So 972 divided by 4/3 will give us 729. That is equal to r cubed. To undo a number being cubed, we will take the cube root of both sides. So n square root button, 3 on the outside, 729 on the inside, and that comes out to be exactly 9. So the radius of this sphere is 9 inches. Note, if your volume did not have the pi symbol hanging out and the pi was actually multiplied in, then you would use 3.14 and divide it to the other side. But because both of our given volumes in this scenario have the pi attached there in terms of pi, then we can just cancel it out with the pi symbol on the right-hand side like we did in these problems 8 and 9. We are not going to look at number 10 today. That's something you can try to figure out on your own if you would like, but we covered the basics of spheres. So we have our formula, 4/3 pi r cubed. We talked about what a hemisphere is. How can we find volume if we're just using 3.14? How would we find volume if we wanted it in terms of pi? And then practicing a hemisphere problem and a couple working backwards problems. Your homework for today is going to be the volume of spheres assignment that is going to be due on Monday for an accuracy grade. Please make sure you are showing your work. At the very least, you should be showing what you are plugging into your formula to get out your volume like we did in these example problems. Thanks for listening, and get to your homework.